This is a quick demonstration of some of the computer vision work that I've been doing with the self-driving car engineer program from Udacity. Using the simulator that's provided, we're attempting to get this car to navigate around the course using only front-facing camera images and the outputted steering angle and throttle information. So to do this, we actually drove the car a number of times, collecting these front-facing camera images, provided some pre-processing them, and compared to the steering angles. Throwing that whole lot into a deep learning algorithm, done in part by the work done by NVIDIA and other companies, I'm able to produce a model that estimates what the steering angle should be based upon new incoming front-facing camera images. So I used two basic driving models. Udacity provided a very good data set that steered through the middle of the course, and it is very well suited to this track. In the upper right-hand time, is the custom model that I tried to get something a little bit more robust that will work in multiple scenarios. Given that we're using the simulator, we really only have two scenarios to work with. This track and a future track that will show some of the information that's upcoming. In both cases, we were able to somewhat get a good solution, but you can see the angles are still fluctuating quite significantly. This shows that even though the computer vision is able to navigate the course, and get from point A to point B, we still have to augment it with quite a bit of other technologies as we go forward. And I'm sure as the course continues on, we'll do a little bit more work on lane finding in the computer vision side, and then some integration with some of the other sensors that go forward. Now that we're into the second track, you can see how the custom model is able to still navigate through the course, even though there's variations left to right. It'll float up and down the horizon, and there's significantly more curves in the course. The deep learning algorithm does require a significant amount of data sets. I think I needed around 40,000 data points for this data set for it to be able to navigate correctly, but it still manages to stay somewhat on the road, at least enough to get through the course. This behavioral cloning algorithm, which is what it's called, worked very well for me, and I think it's a good tool set going forward. Thanks for taking the time to look at the project, and if you look down below, all the links to the source code and textual updates are down below provided, and if you have any questions, feel free to throw them in the comments. Thanks.